All right, so let's continue with the work we're going to be doing today. We're going to be first primarily looking at some written expressions that use these vocabulary terms so that you can see how you should write them. Now, when you see these vocabulary terms in an expression, sum, difference, product, and quotient, the order matters. The way that it's laid out in your written expression is the way that you should write it as an algebraic expression with your numbers. So for example, I'm looking for the sum. Remember, when I see the word sum, it means addition, the sum of 4 and a number. So when I write this out, because of the way it's written, the 4 is first, then a number, which we know is a variable, goes second. I'm going to write my 4 first, addition, because I'm asking for the sum, the answer to 4 plus, and then a number, and I can just write whatever row I want. So 4 plus y, notice how it follows the same order as it was written. 4, and then a number is second, which is why I have a variable there. Same thing when it comes to product of 3 and 2. Product means I'm multiplying. What am I multiplying? I'm multiplying 3 times 2. Order matters when you see those vocabulary specifically. We'll talk about in a second when you see different words that represent the same operations. But when you see sum, product, difference, and quotient, the order matters. 3 was written first, so I'm going to put 3 in front. 2 was second, so 2 goes in the back. Let's go to the next one. Difference. What does difference mean? It means subtraction. Difference of a number, well, it's going to be a variable, so I'm going to replace that with the z. I just picked a random one of a number and 3. So my expression is z, because it's first in my written expression, minus what? Minus 3. Same thing with this one. Quotient. What does quotient mean? Exactly means division of a number and 2. Of a number, I don't know what that number is. It's going to be a variable. I'm going to make it n this time, and 2. So it should be n divided by 2. Notice how for each of these types of problems, the order mattered. When we use these vocabulary words, specifically sum, product, difference, and quotient, I want to make sure that the way it's written in my written expression is how I represent it in my algebraic expression. 4 was first, so 4 is first here. A number was second, so that's why my variable is second. And so on and so forth for each one of these. Let's look at some examples for different types of words or phrases that represent the same operation. So here's a list that you will also see in your Google Classroom. And there's a lot of different words that you can use to represent the same operation. You can see here for addition, you can use altogether, total number, add, or combine. There's a lot of words that are not on this list as well. Same thing for subtraction, multiplication, division, and then the equals. We'll get into the equal part when we get to equations, but we're just going to focus on addition, subtraction, multiplication, division. So there's a lot of words that can be used to represent the same operation that aren't sum, that aren't difference, that aren't product, or that aren't quotient. For these words, I want to attack it a different way because I know it can be kind of confusing when they don't specifically tell you that you're looking for an answer. So for example, let's look at this problem right here. So we want to understand how written expressions work. So it's asking for 2 more than a number. Remember that what it's really asking me for is how to find the answer. So I can add my answer is in front of this to get a better understanding of what it's asking me. So technically, what it's asking me is, my answer is 2 more than a number. Well, let's look at this in other contexts to see if this makes more sense to us. We can actually think about what that expression should be. So let's say John has $2 more than Dave. Well, if Dave has 5, how much does John have? Well, if John has 2 more, if Dave has 5, then John should have 2. If Dave has $2, John has 2 more than that, so that means John will have 4. So I'm always adding 2 to whatever Dave is. And that same thing applies here. My answer is 2 more than a number. That means that no matter what my answer is, if I know let's say my answer is, well, let's say I'm looking for an answer that is 2 more than number. If I know my number is 6, 2 plus 6 is 8, my answer is 8. So technically is 2 plus a number. 2 more than a number. This word more than tells me it's an addition problem, okay? 2 more than a number. So my expression should be 2 plus n. Let's look at another example of this. 2 less than a number, once again, I want to add the in the beginning because it's referring to how to get your answer. So my answer should be, my answer is 2 less than a number. Let's also think about this in context. I'm going to use the money as well. Jimena has $2 less than Joel. That means if Joel has $4, Jimena should have 2 because I'm subtracting 4 minus 2 to get how much Jimena has. In this case, the less than part that I'm referring to here means that I'm subtracting. Well, what am I subtracting? I'm subtracting $2 from whatever Joel has to figure out how much Jimena has. And the same applies to the way it's written. For me to get my answer, I need to subtract $2 from my number to figure out what that answer is. So in this case, my expression should be n minus 2, because I am taking away $2 from whatever that number is to get my answer. Let's do one more. 3 times a number, once again, because when it's written, it's telling you how to get an answer. So I can add the phrase my answer in front. My answer is in front. My answer is 3 times a number. So that means if I look at this in context, Alexander has 3 times as many cards as Brenda. If Brenda has 2 cards, I have to multiply 2 times 3 to figure out how many Alexander has. So when I write this expression, for me to get an answer, if it lets me click out of this, thank you. For me to get an answer, I know that however many this number is or this variable is, I have to multiply it times 3. And we know that when we represent this as a coefficient, as a variable, my number that I'm multiplying times a variable always goes first. So it's 3 times a number. And you could have written it like this if you wanted to, but we can also replace that with a coefficient, the number that I multiplied to my variable, and you could represent it as 3y as well. Either way works, but we just need to know that I am multiplying the 3 times whatever my number is going to be, which in this case, it's a variable. So you're going to be doing some more practice on this here in just a second for your independent practice. Best of luck, and I will see you all on, well, tomorrow, actually.